Hello world, welcome back. In this section, we are covering what I like to call surprise, it's back to the basics. You're probably wondering, why is it labeled like that? Well, it's because this section, we're going to be focusing on the fundamentals of data structures and algorithms. I want to reassure you that it is so important that you are strong in the fundamentals. Even if you've been in the industry 10, 15 years, when it comes to doing interviews, you will be expected to write code on a whiteboard, and the questions that you'll be asked lend themselves directly to the fundamentals of data structures and algorithms. See, I've had candidates complain to me, why do managers ask questions about the fundamentals where I'm inserting a node into a singly linked list or searching a binary tree for a node? Why do managers ask me such easy questions? Because I haven't had to write this code in a long time, and I've used libraries for doing that. I just haven't had to do it. And when I say easy questions, what I mean to say is primitive. Well, here's the main reason. There's only a short amount of time in the interview, and if the manager were to ask you a more complicated real-world problem, chances are you wouldn't be able to get through the entire coding exercise in time. And it would not allow you the opportunity to demonstrate the full breadth of the software development lifecycle and doing that implementation. So don't expect that you're going to get a really difficult question in the interview when it comes to coding. Expect that you're going to get questions that are based on the fundamentals. Data structures and algorithms will be the focus. This is the minimum bar. There are a lot of engineers out there that want to write code at large software companies that don't have the background in the fundamentals to pass an interview. So if you're going to be interviewing at Google, Microsoft, Facebook, Amazon, these companies are going to get you to write code, and you need to be prepared to write implementations quickly and easily and effortlessly, and you need to have a strong understanding of the fundamentals of data structures and algorithms. Also, you're going to be expected to understand how to communicate the complexity of an implementation that you come up with. So you're going to be expected to be able to describe in big O notation whether or not your algorithm is linear time or quadratic or exponential, etc. Now, what kind of coding questions will you get in an interview? Well, the ones that were common when I was last interviewing candidates are these. For instance, I like to ask, search for an integer in an array of integers. Seems really easy. But like we've talked about, qualifying the unsaid requirements will give you a lot more information in order to understand specifically how you're going to implement it. It's a simple problem. You should be able to get through it pretty quickly, maybe 5 to 7 minutes, and it's good. The next one, compare two strings. It's like string compare. Pretty simple. If given two strings that you will compare, if they're equal, you'll return 0. If they're non-equal, you'll return a non-zero value. Clarify what those return values should be when you're in the interview so that you implement it appropriately. The next one that is very common and simple, reverse a string. Usually in place, you should qualify that. Are you going to be allocating a second string to put the reverse string into? Well, usually chances are it's going to be in place. The next one, reverse a singly linked list. I love this question. It's a classic. I like this one. I have a good story about this. I had a candidate that was answering this problem. And of course, the traditional implementation requires that you have a previous pointer and a current pointer and a next pointer. And that as you are moving these pointers through the singly linked list, you can reverse the pointer so that the next pointer points to the previous while keeping track of the next pointer so that you can move to the next pointer and repeat the operation until you get to your termination case. So this candidate was implementing this on the whiteboard, and his implementation wasn't quite clear to me. So I'm looking at the whiteboard and I'm like, what is he doing? And then I had this epiphany. I realized, oh my gosh, I think I see what you're doing. Are you using two stacks in order to reverse this list? And he turns to me and he says, no, but that's a great idea. So it's fun when you're in the interviewer role, the opportunity to see the implementations of different people can actually give you a lot of insight into the way that you look at problems. And like that moment, I had this shift, a bigger, simpler solution kind of popped out. And even though the candidate wasn't actually trying to say that, it's nice. It's fun to be able to have those moments of realization and to learn from interviews. Now, the next common coding question is search for a node in a binary tree. Pretty straightforward. You can probably find the implementation right on Wikipedia. The next one, remove a node from a singly linked list. Seems pretty simple. You'll probably be passed a reference to the beginning of the list, and you'll have to remove it. Remember for the test cases for this that you handled the null case as well as the single node case. It's a good question. The next one is remove the duplicate integers from an array of integers. I've already talked to you about this just in this last section, but it is one of my favorite questions to ask, given that there's so many opportunities to clarify unsaid requirements. Now, the reason why I'm showing you these coding questions is because you should have a list of questions that you practice over and over and over again on a whiteboard. What I do is I have a little small whiteboard that I carry around with me. I'm actually looking for it because I thought I had it in the room here. Oh yeah, here it is. So I've got this whiteboard that I can put into my backpack, and I will pull this out anytime I need to practice a coding exercise. I'll have dry erase markers with me and a small rag, and if I'm on the bus, or if I have some time, I'm waiting at the restaurant, or have some time to kill, I'll pull it out and I'll practice, and then I'll put it away. As soon as I finish the solution, I'll erase it and I'll start again, and I'll do it over and over and over again. It makes me so comfortable that when it comes time to write on a whiteboard, in person, in an interview, in front of a manager, I'm literally ready. I don't have as much anxiety as I would have if I was doing it for the fourth or fifth time. Basically, you want to have done it many, many, many times. So these coding questions represent a good set of questions that you can practice over and over again, and it will help you be prepared for your next interview. Now, let's talk about data structures. Remember, some candidates who've been around for a while, they're like, look, I just use libraries to handle all of the operations on data structures. But you need to be able to do this from scratch. So be prepared to implement the 4 common CRUD operations on collections for arrays, strings, queues and stacks, linked lists, trees, graphs, hash tables, heaps, and throw in a priority queue there as well. These data structures, you should be intimately familiar with the complexity of each of these CRUD operations on and for each of these data structures. Each one has its advantages and disadvantages, and being able to weigh those and communicate those differences in the interview is going to help set you apart from a lot of other candidates. Now, Big O notation. This is a fundamental computer science term that helps to describe what the complexity of an algorithm is. If you're unfamiliar with Big O notation, you need to read up on it, go to Wikipedia, find the article about it, and learn about the different ways to characterize the worst case running time of an algorithm. There's 5 or so most common Big O notations. First, exponential. It's kind of the worst. It's like O to C to the N, basically. It's pretty terrible. I think, I'm not sure, is bubble sort exponential or not, or quadratic? I'd have to look that up. But next is quadratic. That's basically O of n squared. And there's a couple of very simple algorithms that you can implement, both for sorting algorithms and for searching algorithms, that quadratic is the way to express what the complexity of that algorithm is. Again, look it up on Wikipedia. When you're reviewing each of the fundamental data structures, pay attention to what the complexity is for the different type of operations. Now the next one is Big O of n. That's a linear notation, and its complexity is pretty simple. For each element in the collection, you're going to be visiting that collection once. Now the next Big O notation is logarithmic. This is usually O of log n. Sometimes it depends. You might see O of n log n. But the point being that anytime that you subdivide work and reduce by half the number of elements that you'll be visiting in a collection, chances are it's going to be logarithmic. Again, on Wikipedia, for each of the operations, for instance, if you look up a binary tree or look up the performance of a binary search, it will describe for you that it performs in a logarithmic performance characteristic. And the last one is constant time. The type of data structures that are most commonly constant time are hash tables or hash lookups or indexing into an array. Basically, regardless of the size of the collection, the time it takes to visit an element within that collection is going to be the same amount of time. If you have one element, it's going to take the same amount of time as if you had 100 elements and you are accessing the 100th item. So be prepared to talk about Big O notation and about the complexity of your algorithm. It's one of the fundamentals of computer science, and it's required when you interview for technical positions. Next, let's talk about the searching algorithms that you should be familiar with. A linear search, that's pretty straightforward. You have an array of integers. You're looking for an element in that array. You'll visit each element once until you find the element, probably returning its index or true or false, declaring that you've discovered and found that element. Linear searches, practice the searching for an element in an array to help you with that. The next one is a binary search. This is usually operated on ordered collections. You can do a binary search on an array. You can do a binary search in a binary tree. Point being that its performance characteristics are log n. It'll be logarithmic because every time you go to search into a new position, you've removed half of the entire set to search. And the last searching algorithm, which you should be intimately familiar with, is a hash search, where regardless of the size of the collection, most of the time, the time it takes for you to access any particular element is going to be in constant time. Review the fundamentals of linear search, binary search, and hash searches by reviewing the contents that are on Wikipedia. It will help you perform better in the interview. Now let's talk about sorting algorithms. These algorithms you should be able to write up and code without any assistance, meaning you need to practice these over and over again. Do it on a whiteboard, whether it's a portable whiteboard that you carry with you in your backpack or a large whiteboard in a conference room or at home. But practice these sorting algorithm implementations as many times as you can. The easier it is for you to write these up, the better you're going to do in your interviews. The sorting algorithms of particular note is the world famous bubble sort. Its performance characteristics are pretty horrible. The next one is the insertion sort. Again, you can find this online on Wikipedia. The next one is the selection sort. Some of these algorithms are really good for, say, reshuffling a deck of cards problem. I like the selection sort for that. Also, the merge sort. It has better performance characteristics than all of the previous three sorts talked about. And then the quick sort. It's even faster. But it's interesting. It's got some little quirks. Go discover what those are if you're not familiar with them. It's a great little algorithm. And the last sorting algorithm that you should be comfortable with is a radix sort. Understand how each one of these sorting algorithms are implemented, memorize how to implement them, be comfortable so that at the drop of the hat, you can just jump on the whiteboard, implement it, and you're done. So, in summary for this section, you want to review data structures and algorithm fundamentals. Go to Wikipedia. It is a fantastic resource. Use that to get you started. Next, understand the advantages and disadvantages of the common data structures and the common operations that you will do on them. Be prepared to talk about big O notation and how it's used to describe the performance of your algorithms. And then practice the aforementioned coding questions on a whiteboard until you are so sick and tired of it that you don't even care if you get a job. That's a pretty good place to be. Also, remember, practice coding up iterative solutions as well as recursive solutions. Both have their advantages and disadvantages, and if you choose a recursive solution, just note it might make it more difficult for you to use the whiteboard development environment and the debug stack in order to debug your code. But I love iterative solutions. Recursive is cool, but you know what? Each has its place, and it's better to be okay for both. All right. As far as interview preparation resources, I'm just going to list two. I've already mentioned Wikipedia. Check out their data structures section and look up all of the different types of data structures we've talked about so far, as well as the sorting algorithms. The second resource is a book that's been around for many, many years, and I found it very helpful in my early career to help me prepare and understand how to approach the very simple coding questions that are asked. It's called Programming Interviews Exposed. And I still think it's a great book today because it does focus on the fundamentals of data structures and algorithms. I recommend read chapters 2 through 6. It will set you up for success in a pretty effective manner. All right. That's it for this section. Remember, these fundamentals of data structures and algorithms are critical for you to be able to pass a technical interview. If you're unprepared to implement any of these aforementioned data structures and or sorting and searching algorithms, then postpone your interview and practice. Practice until you are really good at it, and then resume your job search and ask to have that interview scheduled. You won't regret it. There are jobs waiting out there for you, but you need to be prepared to succeed in the interview. And practicing the fundamentals of data structures and algorithms is going to help you do that. In the next section, we're going to be covering closing the interview. Basically, that last 5 minutes of the interview, what should you do and maybe what should you avoid doing? We'll cover that in the next section. I'll see you there.